Okay, today we will be discussing about Tappet, and deflection. So first we will have to go with firing order. So what is firing order? So firing order is the sequence of combustion per cylinder of an engine. So the engine usually don't fire, the engine cylinders don't fire at the same time. So it must be fired one at a time until to prevent bending or damage to the crankshaft, especially if both two cylinders fire at the same time. So the crankshaft that holds all the that absorb all the power or the force from the piston or from the reciprocating motion will be damaged. So let's go. So first we have here a situation. So we have a 6-cylinder 4-stroke diesel engine is equipped with one turbocharger. So the exhaust piping to the turbocharger is connected using the pulse gas flow system. So question. So the engine is running clockwise. So question: what is the crank angle between two power strokes in this engine? So this is a 4-stroke diesel engine. So as you can see, 4-stroke diesel engine rotates twice or has 2 revolutions to complete the 4 events, which is the intake, compression, power, and exhaust. So 2 revolutions is 2 revolutions divided by the 6-cylinder, that is our crank angle between 2 power strokes. So we will have a computation later. And then B, draw the crank circle with one of the possible firing orders. And then C, which firing orders are possible for this engine. D, draw a schematic top view of the engine turbocharger, air cooled charger, receiver, and exhaust gas piping. E, explain the layout of the exhaust gas piping to the turbocharger and what are the requirements for the dimensions of the exhaust gas piping. Okay, first, what's the crank angle between 2 power strokes in this engine? So as we all know that 4-stroke engine has 2 revolutions. So 2 revolutions equals to 720 degrees. So this one, 720 degrees, divided by the number of cylinder, which is 6-cylinder. So the crank angle between 2 power strokes in a 6-cylinder engine is 120 degrees. So in every 120 degrees, one cylinder creates a power stroke or has its power or combustion. Okay, for B and C, we will draw the crank circle and the possible firing order. So first we will make a circle here and then put the number 1, 2, and 3. And since it's not stated in here, so since for an engine, so let's write an engine. Okay, if we have an engine with 1, 2, 3, 4, 5, 6-cylinder. So the 2 cylinders on each side, on the opposite side, are called running mates. So this one and 6 are running mate, 2 and 5 are running mate, and 3 and 4 are running mates. So if you put it in here, so for example, the rotation, we have a circle, and then the rotation is clockwise. The turning direction of the engine is clockwise. So as you can see, this one is checked clockwise. And then we put number 1 in here, and then the next cylinder that will go up will be this one here, right? So we put number 2 in here because it's the next cylinder that will move upward. And then we put number 3 in here, right? And then it's, as you can see, since 1 and 6 here, 1 and 6 are running mates, so we put 6 on this side. If number 1 is on top dead center, also 6 is on top dead center because they are running mates. So both are, the running mates are the cylinders that are in the same direction from each other. Okay, next, for number 2, the running mate is 5. As you can see in here, 2 and 5 are the opposite cylinders. So 2 and 5 you put in this one. Okay, and then the next one is number 3 with its running mate, which is 4. Okay, so let's now check the possible firing order. So first, if we will go with the odd number, all odd first, odd number, we will go with 1. Always remember that firing order starts with number 1. So even if it's an even number firing order, we still start at 1. Okay, so let's go. For odd number first, the one will got its firing will be 1. Next will be 5 since it's an odd number. And then next here will be 3. And the next one that will fire is number 6. The next one will be 5 and 4. 3. Oh, it's even, but so 6 and then 2. So this one is 2 and 4, and then it will go back to 1. So it is a complete cycle. It will go back to 1 and then 5 3 6 2 4 1 5 3 6 2 4 and so on. So that's how the firing order works. Okay, so that's for the odd number. But if the firing order is an even number, so we will start with 1 and then we will continue with an even number. So 1 here, next to fire will be 2, next to fire will be this one, 4, next to fire will be 6, and then odd number 5, and then 3, and then here firing order fire will be 1. So that will be, so let's check, 1 2 4 6 5 3 1, that's correct. 1 5 3 6 2 4 1, that is correct. So that's how we get our possible firing orders. But on ship, of course, we will always check the manual for the firing order of the engine. Okay, let's go with the next slide. Draw a schematic top view of the engine, turbocharger, air cooler, charge air receiver, and exhaust gas. So if this is your engine, we have 6 cylinder, as you can see. We have here the turbocharger. We have air cooler. This one is the air cooler, charge air cooler. And then this is the intake manifold going into each cylinder. Okay. So if we will go with the even number, for example, we have the even, the firing order for the even firing order is 1, 2, as you can see, you can check from the previous. We'll check from the previous. We have 1 2 4 6 5 3 1. Okay, 5 3 and back to 1. Okay, so let's put our exhaust gas piping in here. So usually for a pulse type we have 2 or 3 exhaust manifolds. So in this sample we have only 2 exhaust manifolds. So let's see. So first manifold we got 1. This one is connected to the first manifold. Okay. Number 2 is connected to the second manifold. So as you can see in here, this is the second manifold. And then 4 alternate. 4 will go with the first manifold, that connected to that one. 6 will be connected to the second manifold, as you can see. 5 will be on the first manifold, and 3 will be on the first manifold. So as you can see, there is an alternate manifold for every firing order. So 1, 4, and 5 are on one cylinder, one exhaust manifold, and 2, 6, and 3 are on the other cylinder exhaust manifold. It means that every firing of the cylinder, one very short and narrow pipe exhaust manifold is supplied with exhaust. So it is narrowed and shortened and narrowed so that the pressure will be there will be a pulse to be given to the turbocharger exhaust side so that it will run faster. Okay, so there's a separate manifold for that. So as explained, so this is letter E, not F. So explain the layout of the exhaust gas piping to the turbocharger. So in a pulse type system, the exhaust gas piping from the cylinders to the turbocharger are kept short as possible, and the diameter of the piping is narrow. So the result of this construction is that as soon as the exhaust valve of a cylinder will open, the exhaust gases entering the exhaust gas piping will create a pressure pulse. So this expansion of the gas will take place in the exhaust gas turbine, giving additional energy to the rotor of the turbine. So after the exhaust valve is closed, the pressure will drop. By combining different cylinders which have their exhaust gas stroke started closely after the previous cylinder has finished its exhaust gas stroke, a new pulse will enter the exhaust gas piping. By this construction, a continuous flow of pulses is sent to the turbine. So on the six-cylinder four-stroke engine, we divide the exhaust gas pipe into two subsystems to avoid overlapping of exhaust strokes of cylinders. So when an engine is equipped with a pull system, the period that the inlet and exhaust valve are overlapping is larger as the pressure in the exhaust gas piping is relatively kept higher due to the short and narrow piping. So in order to get a good scavenging effect and sufficient clean air in the cylinder, the exhaust valve is kept open longer also. So for letter F, what are the requirements for the dimension of the exhaust gas piping? So the diameter of the exhaust gas piping is kept narrow in order to avoid expansion of the gases before entering the exhaust gas turbine. So this is for the pulse type exhaust gas system. Okay, so that's it for firing order. Now we will go to valve timing. So valve timing is putting a gap in here, in between the rocker arm and the valve, intake and exhaust valve. So valve timing is the critical relationship between the position of the crankshaft and the opening and closing of the inlet valves and exhaust valves. So the valve train is geared or has a chain drive with sprockets on the camshaft and crankshaft. So any slight variation with the correct timing setting will result in loss of power and overheating. Any large variation and the engine will not start. Okay, so to accurately check the valve timing, it will be necessary to remove the timing cover to gain access to the timing gears. The gears or sprockets are fitted to the crankshaft and crankshaft by keys, so they can only be fitted in one position. However, they can be incorrectly lined up to each other. So the operation manual will indicate that the timing marks look like, and in the case of chains, what the sprockets should line up with. The typical lineup marks for gears are shown below. So here is a timing marks. Okay, so valve timing. When timing has been found to be correct, the tappet clearance, also referred to as valve lash, should be checked. Whenever the cylinder head is overhauled, the valves are reconditioned or replaced, or the valve operating mechanism is replaced or disturbed in any way, the tappet clearance must be adjusted. Also, when the cylinder head has been retightened after the initial run-in period. So let's go. So too much clearance will cause excessive wear, noisy operation, and altered valve timing. That is late opening and early closing. If the clearance is insufficient and the valve does not sit properly, it will result in loss of compression through valve leakage, burning and eroding of the valve and seat, and general overheating. So in the extreme, it is possible that the piston could strike the valve, resulting in a bent valve system, or madamage yung valve mo, mabali, maputol. So damaged piston, or worse, the valve or piston should break. If the valve operating mechanism is disturbed in any way and the engine is cold, but only a hot tappet clearance is given, the tappet clearance must be checked. If required, further adjustment when the engine is at its normal operating temperature. So always check your manual what is the correct temperature on doing this valve timing or tappet clearance. Okay, so how do we do this? So we have here a valve clearance. So we will just loosen this lock nut. This one, loosen this lock nut. And then if this one is loosed, we can adjust using the adjustment screw, and then put a feeler gauge in here, which is have the same gap on your, depending on your manual. So put a gap, put the feeler gauge, and then if the gap is now good, so you can adjust the screw, adjust the gap. If it's good, you can lock the lock nut now, and then that's good. Okay, that's why how rotate this lock nut was loosened, and then rotate this adjustment screw, and then put a feeler gauge in here depending on the clearance that is given by the manual. So recheck the clearance after locking, or if it's okay, if everything is okay, lock the lock nut and then recheck if it's the clearance are correct. Okay, so when to check or adjust tappet clearance? First, during regular maintenance, engine manufacturers usually provide a maintenance interval for tappet clearance, which is typically, or depending on your manual, or depending on the engine type. Okay, after major engine work, if you have done a major repair or valve work, it's a good idea to check and adjust the tappet clearance. Okay, during performance issues, if the engine exhibits signs of poor performance, rough idling, or increased noise, tappet clearance should be a factor. So how will you check if your tappet clearance will be now okay? So we can do the we can hear it using a screwdriver or a stethoscope, and then you here each cylinders, if it's not noisy, then it's all good. If there's, compare the noise of every cylinder head. Okay, you can also do that, or you can use the spring, what you call it, the indicator diagram. You can check if it's the exhaust valve is okay. So okay, that's it for tappet clearance. Now we will go to the crankshaft. So the crankshaft is an engine main component which is responsible for the conversion between reciprocating motion and rotational motion. So the crankshaft of the marine diesel engine is a huge bulky component which should remain as straight as possible during operation. So how will we check if the crankshaft deflection or your crankshaft is in alignment or it's straight form? Okay, so we will have to do the crankshaft deflection and plastic gauge. So what is crankshaft deflection? It indicates the misalignment of crankshaft due to the worn out of the main bearing. So these are the devices that we can use. We have here a dial gauge with an extension. We can also use a digital type of measurement to measure the space between two what's this, crank web. Okay, so that's one. So that's it. So you just have to put this one. So this is our indicator, dial indicator, and then you put it on this position, and then you adjust to 0, and then you adjust here to 0, and then after that you rotate the engine. When it goes in here 90 degrees, measure the reading. Okay, measure the reading, and then rotate again 90 degrees, bottom dead center, measure again, and then rotate again 90 degrees, then measure again, and then you put it in here on this part, and then measure it again. So you can see different readings. So for example, this one 0 mm adjusted. In this one we have positive and negative and positive and positive. So that are the readings. So how will we check if it's okay? So we will put it in a baseline. We have a baseline here, we have a deflection curve, and then we will put the negative, positive. So negative means that the crank web is shrinking or has a smaller distance, while positive means that the crank web is a little bit far from each other. Okay, so if the crankshaft, we will check the manual, we will check the sea trial, the acceptance test record. We will check if all your readings are on normal, are near from the previous readings or from the sea trial reading, and also check if it's still good based on the manual. So if it's not good, the clearance are very big, so or are not under the base, more than based on the manual, so we should should check our bearings. So maybe the bearings are damaged, the bearing is clearance is too big or something like that, so that we can put the crankshaft back to its normal condition alignment. Okay, so bearings could be damaged like this one. So a slight discoloration or a scratch on our bearings, you should check the problem and replace the bearing already. So don't wait that the bearing will be damaged like this before you replace it, because it's a very big problem if the crankshaft will be damaged. So the one that protects the crankshaft from being damaged is the bearings. So replacing a bearing is a very easy task, but replacing an entire crankshaft is not a good way, or you will be maybe I've been experiencing that some chief engineers have been replaced due to that circumstances, crankshaft replacement. So it's a big deal, it's a big challenge to the crew, a big investment or a big expenses to our company, and a big problem to the engine. Okay. So understanding the engine crankshaft deflection measurement will aid a diagnostic engineer. So before a damage will happen, so you have already replaced your bearing and you have already rectified the problem. Okay, the crankshaft of the marine diesel engine acts as the outlet of power for the engine for supply to the huge propeller immersed in the sea, which helps to propel the ship forward. So learn about the construction and design of a marine crankshaft. So there are forces on the crankshaft. Due to its nature of operation, there are several types of forces which come to act upon the crankshaft of engines used in marine propulsion. So you will get a better idea about these forces if you take a close look at the image shown below, which shows the various twisting and bending force. These are the twisting and bending force in the crankshaft. These forces are due to a variety of factors, including but not limited to the weight of the pistons, combustion loads, the axial loads from the propeller which is immersed in the sea, compressive loads of webs or on journals, and so many forces. So the rotational power of a ship's propeller is determined by the power produced by the marine engine to rotate the crankshaft. So the crankshaft of the main engine is supported and connected to the connecting rod via main bearings, whose main function is to transmit the load without any metal-to-metal contact. So worn main bearings like this. So the first and second layer is now not good. So the bronze layer, or this one, this like bronze type like color, is shown. So crankshaft bearings should always be replaced when you are rebuilding an engine because the bearings are a wear component. So heat, pressure, chemical attack, abrasion, and loss of lubrication can all contribute to deterioration of the bearings. So consequently, when an engine is rebuilt, new bearings should always be installed. So the bearings has many layers. So this one is the third layer, is that copper lead lining, high fatigue strength. Okay, so that's not good if the color has changed in our bearings. Okay, so proper preparation prevents pathetic performance. So apart from using the same point the crank web for measuring deflection, there are other factors which need to be kept in mind if it is a marine installation. They include load on the ship, trim, hug, sag, etc. The vessel must be afloat at the time the readings are taken. Draughts forward, aft, and if possible, draft forward, aft, and if possible, amidship, both sides. So vessel ought to be unladen if she is a cargo carrying vessel. To some extent, those points are a bit like gliding the lily with the vessel under about. So there are different things that you should consider in doing your crankshaft deflection. Okay, continue. Okay, there's a plot of deflection readings, plotting of the readings. Okay. Okay, so let's go. So when to take the main engine crankshaft deflection? First, after a major overhaul or maintenance like bearing replacement. Second, when engine vibrations or unusual noises occur. Third, periodically as part of routine inspections or manufacturer's recommendation. Fourth, after engine performance issues like loss of power, excessive oil consumption, or pressure issues. So you should always check your crankshaft deflection. Number 5, for post-cranks or after external forces like sudden stoppage or overload of engine, sudden stoppage of engine, or after an impact of collision, impact of the ship, collision or grounding, you should do a crankshaft deflection. Or on special situations like when the crankshaft alignment is suspected to be, if you suspect that there is a problem in the alignment, so to double check, use a crankshaft deflection. And when you see bearing scoring or damage, so you should always do a crankshaft deflection. Okay, so let's go now with the third one. We'll go to the plastic gauge or plastic gauge. Okay, plastic gauge provides a simple and effective method for the measurement of clearance between fitted or hidden surfaces. So it is particularly useful for measuring clearances in split bearings or in situations where a filler gauge cannot be inserted. So plastic gauge should be used to measure the clearance between engine bearing surfaces and the crankshaft journal in main engines. So it is recommended that surfaces have been clean prior to use of plastic gauge. So clean it first, and then place plastic gauge placed across the bearing surface. You put that, and then put something like a grease or a so that it will hold, it will not move, and then compress the plastic gauge ready for compress the plastic gauge put the bearing cap and then lock it to the correct tightening measurement, and then after that you remove the cap, the bearing cap, and then you will see that the plastic gauge is flat like this one, is compressed, and then depending on the how it was compressed, you can check the measurement of the clearance of both surfaces. So there is a paper like this, a measuring guide, so that you can check how thin this plastic gauge will be. So that is the clearance of your bearing and main journal clearance. Okay, so you can see here we have a digital. We have an inch and a millimeter reading, so you can compare this one. So attention, don't rotate the crankshaft because the plastic gauge will be flatter than what it's supposed to be. So when to take plastic gauge? So first, during assembly or reassembly, after overhaul or major repairs or bearing replacement. Second, when bearing clearances are suspected to be out of tolerance, like engine performance issues. Number 3, after a sudden engine stress or incident, after a seizure or sudden stop, following a high load or overload event, during in case of accident like grounding and collision. So you can take plastic gauge as additional measure to your crankshaft deflection during routine maintenance and periodic inspection also, and when precision measurement is needed. Okay. So plastic gauge is a relatively quick and simple method to measure bearing clearance without needing to remove or disassemble the entire engine, making it valuable in certain situations. Using plastic gauge ensures that the clearance is correct and that there is no risk of over-tightening, which could lead to increased friction and premature wear. Always compare the plastic gauge reading to the manufacturer's specifications to confirm that the clearance is within the acceptable range. So I hope you learned something. We have firing order. We have the Tappet clearance. So since Tappet clearance, we will have to do the clearance of the rocker arm and the valve. So the best way to check if you can do the Tappet clearance is by following the firing order. So when the cylinder is on its firing stroke or in top dead center, using the firing order, if it's on top dead center, it means that the intake valve and exhaust valve are not activated because it's in powers during combustion, right? So if the intake valve and exhaust valve are not activated, so you can do the Tappet clearance on this valve. So the intake valve has a smaller clearance than the exhaust valve because the exhaust valve can expand, its metal will expand more because of it has high temperature in the exhaust valve than the intake valve. So the clearance also will be higher. So the purpose of the intake, the Tappet clearance is to compensate for the expansion of the intake and exhaust valve during the running of the engine. So since it will be having an expansion, so we will put a clearance during when the engine is stopped. Put a clearance so that when the engine is now running, the intake exhaust valve will expand and then the clearance will be put back to zero. Okay. And then next we have the crankshaft deflection. So crankshaft deflection is used to measure if your crankshaft is still okay, it's still straight, and then check if the bearing is, if it's not straight, then maybe the bearings are the clearance of the bearings are, there are thinner bearings maybe, or you can also the plastic gauge to check your crankshaft clearance of your bearing and your bearing and your main journal to prevent from over tightening also. So I hope you have learned something today, and I'll see you on our next video. Please do like and subscribe our video. Thank you very much, and God bless everyone.